Good.
All right. So, always. Sorry. So, so the subject of this week's lessons is going to be working with permanent data, working with data that exists on a file system. This is a pretty general skill. The stuff in this lesson particularly, when I used to teach at the university, this would always be included in whatever intro programming class you were taking. But here, there's just like I actually talked to some of the professors about it, there's just like no good place to put it until now in the program. So normally this sort of thing would be covered much earlier, but you know, things being what they are, we're covering this in third semester. So what we are going to talk about is file I/O, file input and output. How many people have had experience with file I/O before now?
Like we had to use it as like an import in like Java and C# and stuff to like, but we don't really know what it does. We just know we need it in there for it to work.
Oh, okay. This is different from including a source code file.
It's also like file.io, so I thought it was.
Oh, yeah. Some of the like in Java, the you'll have loaded the functions we're going to talk about come packaged with the same functions that will have like system.print or system.out, whatever it was, system.out.println and that type of thing. So in our case, today we're going to focus on reading and writing plain text information in files. So let's start off. What's the difference between RAM and ROM? Who can tell me? Yes?
Random access memory and read-only memory.
Right. So RAM, random access memory, RAM chips, right? If you see a RAM chip, it's a bunch of chips on a thing, you plug it into your motherboard, right? That is essentially the space that's used by the variables declared in your program, right? Any impermanent memory gets stored in RAM. There are a couple of other sources, a couple of different types of memory, like cache memory and register memory in the CPU, but your main memory unit will be your RAM. We call it memory. What's ROM? In terms of hardware components in a computer, what's the ROM? Someone other than you. That's right, your hard drive. So, the hard drive or solid state drive, depending on how new your computer is.
What is disk drive?
Those are considered read-only memory as well as like USB thumb drives or flash drives. Those are also considered ROM. What we consider in Windows actually, you'll notice that when you mount a USB drive, it assigns it a letter, right? Like E or something. Yeah, those are, that's the way that Windows numbers its mounted drives. So it considers that to be a drive, right? So these are devices on which files are kept. We're talking about the file system, right? Anything with a file system is permanent memory. The thing that distinguishes random access memory from permanent ROM read-only memory is that the information inside of ROM memory survives a power down, a power cycle, right? If you didn't know this, RAM gets completely wiped out anytime the machine loses power. That's why it has to be rebooted from scratch. Right? Make sense so far? So, in this context, we are going to be using PHP to open up, work with files that exist on the server. This is server-side programming. However, it's very important for you guys to know that the functions that PHP is using here are basically a simple exposure of the C standard libraries that do the same. The C standard libraries for file manipulation are used by a very, very large number of programming languages in the backend. Python, for example, uses the exact same C library functions to perform the same processes. And you may be saying, okay, so why do I need to know this? The process that you follow in PHP to open and work with a file is the same as the process in every other language that you're likely to work with. The only thing that will be different is there may be slight differences in the function names that are used. There may be slight differences in the arguments that those functions expect. But it's kind of like your Dark Souls to Bloodborne problem. You just have to learn what everything's been renamed, you know? So, good. Security. So, last week we talked about cross-site scripting attacks. We talked about permanent stored attacks, and we talked about transitory attacks. Stored attacks are worse, right? Question: where are stored attacks stored? Answer: files on your server. No matter how good your data filtering was going in, taking information from the client, an important principle in security is that you never assume that one layer of security was good enough to fully protect, right? Just because you set up all of your validations correct does not necessarily mean that something didn't slip through, because hackers are very clever. So, when we work with files that exist on the server, we treat them with the same level of skepticism that we treat data originating directly from the client, because this data also originated from the client in most cases. Unless it's like some kind of internal configuration file that never, no data from the client ever enters it, the only thing that communicates it with it is PHP scripts. In that case, you can be reasonably confident that it's not a problem. But you should consider any files you're reading from the server to potentially contain attacks and malware. You guys know what the word malware means? Sometimes people don't. Okay.
So this is a software development place,
Yeah, I know, but I learned a long time ago that you should never assume. Right?
That's fair.
And I know, one of the things that is a hang-up for people some of the time is when somebody's standing up at the front of the room using a bunch of words they don't know what the meaning are, you know? So, all right, so files then. Files come in two flavors, two different types of encoding. You have text-based files, and you have binary files. Text-based files are character encoded. So if you open up the file and take a look at the insides of it, you can actually read it because it's composed of characters. Binary encoded files are not character encoded. They represent raw binary data. The easiest and most immediate example is image files. Image files are not character encoded, they're binary encoded. They're a bunch of numbers representing pixel values, usually with some degree of compression. So, if I make a plain text file, and I open it with Notepad, this is a text encoded file. I can write text in it using a keyboard, and everything is cool. If I were to grab an image file off of the internet, for example, ABIF. ABIF is everywhere these days.
Who's Abbott?
ABIF is AVIF is a new image encoding standard, which is apparently better than JPEG, which has been, it's been increasingly, it's like taking over. It's new image format that's taking over. It has better compression than JPEG with less lossiness. So, .jpeg. So there's our duck. But have you ever wondered what happens if you try to open one of these things with something that it's not meant to be opened with?
No, sir. What happens?
This is what happens,
Oh, yes, I love Notepad. Yes.
right? So what's going on here, you can see all of these like very strange symbols going on, right? This is not character encoded data, but if what the Notepad application does is it chooses to interpret it as character encoded anyway. So all of these bits, they encode for, like, if you take the bits and you interpret them as characters, you're going to get all these extended Unicode symbols that don't actually, they aren't meaningful in any sense for us to read, but they do accurately represent the underlying binary data. So that's this part will be the header, by the way. So that's a binary file. The techniques we are about to discuss are not useful for binary files. They are only useful for text files. The idea here is that we take a text file and we load it into our program as string data specifically, right? Then we can work with it as if it, we can work with it as a string, and then if we want to, we can put it back where we found it, or we can write it to another directory, or we can echo it to the client, or we can do anything we want with it. So, good. Good feedback. I'm gonna want that picture of a duck later. So, good afternoon. I've already got my XAMPP I've already got XAMPP running, so if you want to open up all of your stuff, XAMPP, VS Code, and that should be good for now. Please do so. So, good. Apache is running. Wonderful. Local host 1080 read 5. There we go. You can see that that's the same as the contents of this directory. So let's write a PHP script. Did VS Code ever actually load? So it goes. This is so much easier than just having the software on the computer. I'm making a new PHP file, fileio.php. I'm going to save that to my appropriate XAMPP folder. In this case, I've got week 5. Fileio.php. So the way that file interaction works, it should be reasonably familiar because most programs that you've used that work with files on the file system follow the same pattern as we will be following in code here. That is to say, you start your program, you open a file, you do some stuff in memory, and then you save the file and close the file, right? Saving here is called writing the file. So, opening a file in a programming environment can be done in 3 basic modes, and then a bunch of other modes as well that we're not going to talk about in this class, but you can look up their behavior if you want to. We have read mode, write mode, and append mode. A very important thing to know about write mode in this is that it is overwrite mode. So when you're in write mode, anything you write to an existing file will delete the current contents of that file. Yes?
Could you also do that with variables on Python?
Overwrite variables in Python?
I think we were told that we could type we could type a variable name and like say change the variable name.
Oh, I see. I guess in a sense, like if you create a variable x and give it the integer 5, and then 40 lines down you assign like a string to x, technically you're overwriting it with a string.
I think specifically it was like int and then string, and string was the name of the variable, and no longer page string.
Oh, yeah, that's not really like overwriting in this sense. That's more a form of polymorphism where you can assign various names of things in a local context to have different meaning. Yeah, in Python, like you can override the definitions of everything but your like very strict keywords like if.
Okay.
But yeah, that doesn't really have anything to do with file IO though.
Okay.
Yeah. So, any other questions? So, this is the sort of thing that you should have a cheat sheet for, or some kind of like working reference. The way that you open a file will cover all of that stuff I scrolled past. I want to get like the working demo working first, you know. The function that you call to open a file is fopen. Stands for file open. Again, a direct exposure of the C standard library function of the same name. So if we want to open a file, fopen, we then have to provide a file name. I'm just going to insert a variable there for now. Then we select which mode we want to open the file in. for now, let's just choose read mode. So to select the mode, you provide a string, and then a single character, R for read, W for write, A for append. Make sense? Good. And there are additional options here that you don't have to worry about, so don't worry about them. In PHP's typical fashion, if this operation fails, it returns false. Otherwise, it returns what's known as a file handle. A file handle is an object containing all of the information necessary for other file operation functions to know which file we're working on. You'll see that for the rest of these functions we see, all of them will require the file handle as one of the arguments, usually the first argument. So, it's always useful to put the file name, like define a variable up at the top with the file name. So in our case, let's say we want to open mytext.txt. Like so. Good. Now, there are a couple of reasons opening a file might fail, but over and above the most common one is that the file you're trying to open doesn't exist, right? So if mytext.txt did not exist in the folder here, then fopen will fail out on a false. A way that you'll see this done in the slides a lot, you'll see something like this, where the function is being called inside of the if expression. I find this to be clunky and confusing and not necessarily, it doesn't make it as clear what's going on, So for the sake of clarity, I usually prefer to take this out and put it up front, and then assign it to a variable, and do it that way. It's up to you entirely which way you want to do it, but I think that this is easier to read and easier to debug. So that's just me. So, the point of the fopen operation is to produce that file handle. Aside from that, it doesn't really do anything. So far, we haven't read any data from the file. We haven't manipulated the file in any way. All we've done is grabbed a working reference to the file. So, it would be useful to do something with it. I'm in fact going to call it FH. I'm going to FH for file handle. That's just a lot shorter. So, the function which allows us to read the contents of a file once opened is fgets, or fgets. That is to say, file get string. This function reads exactly one line out of the file. You may ask yourself, which line does it read? The file handle keeps track of which lines have been read and which ones haven't. It keeps a pointer to where you are in the file, and fgetS will always read the next line out of the file and load it in as a string, as the return result of this operation. fgetS file handle. So the return results of fgetS will be a string if the file still contains string to be read, or if the file has not been completely read. It will return false if you have already reached the end of the file. This can be used, as we're going to see, to determine when you are actually at the end of the file. But we also have another function for that which we can use. So, but first, let us try this out. There we go. I'm going to break something in here. Again, never ever use breaks. Ever, ever, ever.
And yet you do.
Well, I'm trained. I'm a trained professional, you know.
Trained professional breaks.
Yes. So, as we can see, the content which has been echoed to the screen is the content of that text file. Now, the text file only contained one line, and we only have one read through fgetS here. What happens if we add another line? So, what if the text file is slightly longer? We still only get the first line. fgetS only reads one line. It is not possible to know how long the file is when you open it. You can only get there by reading out sequential lines for it. So what we need is a loop that has from the perspective of the program so far, a non-standard stopping condition. The stopping condition here is when I have reached the end of the file, stop doing things, right? File. Now, the function I'm about to use, FEOF, tests to see if the end of the file has been reached. File, end of file. In Unix, and it's the Unix file system that you have to worry about because we're running on an Apache server, a file has as its last character a special reserved character called end of file. That's how a file knows that it's ended. It's kind of like null termination in strings. So, file end of file returns true if we have reached the end of the file and false otherwise. So, we need a not there, basically. Because we want this condition to be true while we haven't reached, we want to read it while we haven't reached the end, right? So we just need the logical negation. Saving that up.
Sorry, can you
Yes. I have markers? Okay. So,
I can mark your stuff, so.
yes, okay. FEOF. File, end of file. Yes. Technically speaking, it's file operation detect EOF, because EOF is the abbreviation for the end of file character, which comes at the end of all files. Yeah, the name is kind of dumb, but there are other ones that are even worse. So, yeah, a little bit. PHP stands for PHP hypertext processor. Yes. So it's detect. So this is actually a good description. Detect EOF. True means you have detected the end of file, and false means you haven't. Which means if we want to read all of the contents and then stop, the loop condition must be true until we hit the end of the file. So we just need to swap these. True and false. Yes, good, excellent. So, there we go. So, we have all of the data, but it's not precisely, it's all been run together. Anybody know why?
It's not copying the spaces, I guess?
It's not counting the spaces, yes. So the contents of the file are being, although there is just a regular string in PHP, once we echo that to the client, it's being rendered as HTML, right? HTML gobbles new lines, right? So all of those lovely new lines we were using for spacing inside of our text file, that's, they're all getting destroyed. So we can, in fact, throw them in. And this is actually an appropriate use of breaks because this is poetry. Poetry is one of the only allowable uses of the break. And song lyrics.
Well,
Song lyrics are poetry.
Yeah, song lyrics are poetry with melody.
Yeah. There we go. Now everything's nice. So, but this should illustrate to you one of the dangers of loading data from the server. So, because this is being read in and rendered as HTML, any stored little pieces of nastiness like this will be executed by the client in good faith, which means if there was an XSS attack in here, I just put it, that's a stored XSS attack. To be vulnerable to it, you don't need to have done anything wrong yourself. All you need to do is visit a contaminated website. So, they are a particularly bad form of web vulnerability. Make sense? So there's one step remaining here. When you open a file, you are requesting access to that resource. And this is an operating system thing, this is not just for servers, right? While we've got this file open, everything that's going on in here, like, without a sufficient level of protection, it's entirely possible that some other user could modify the file while we have it open, right? So we need a slightly more robust mechanism for protecting the file so that we're the only people who can have access to it while we're accessing it. The first step here is to let the server know when we've finished using the resource. So we also have fclose. This is the one that you'll forget most often. As you can see over here, technically the thing still works without fclose. Basically, at the end of the script, when all of your variables are deleted and destroyed, any open file handles, PHP is intelligent enough to go through the proper closing procedures once they hit garbage collection, right? You guys know what garbage collection is? Anybody not know what garbage collection is, because it's kind of an important concept? Okay, so Java is famous for garbage collection. Basically, so you remember how you can have object references in Java, right? When you create a new object, you assign that to a reference variable. If an object has no reference variables pointing to it, there is literally no way for anyone to access it. It's just dead memory, right? So, what programs that do garbage collection, the way that garbage collection works, they keep a table of all of the memory that's being allocated and where, and periodically they stop the program, check all of the existing sort of active variables, and compare the state of the active variables to the declared memory. If the active variables don't have references to some of the elements of the declared memory, those pieces of declared memory are considered to have been thrown in the bin, right? You deleted the reference to it, the memory is no longer accessible, so what garbage collection does is it releases that memory back to the system, right? It deletes it outright and permanently. Since there's absolutely no way for the program to get access back to it, that it's a safe thing to do. But that's what garbage collection is. It runs every once in a while, right? So when file handles are garbage collected in PHP, PHP runs fclose on them. So everything is garbage collected at the end of the file, so in theory, the system resource is released back to the system at the end of the file, whether you call fclose or not. But I'm not giving you an example of code that you can just put in one PHP file and call it a day. I'm trying to give you code that will work no matter where you put it. So that, in that case, basically in all other cases, fclose is necessary, particularly if you want to reuse the variable for another file handle, for instance. Make sense? Just,
Close the damn door behind you.
yeah, close the damn door behind you. Very, very good, very elegantly put. Just free your pointers. That's what we say in C. Just free your pointers. The difference between Windows and Linux is that Linux takes care of stuff like this and Windows doesn't. That's why Windows leaks memory all over the place. So, anyway. So, we have one more command which allows us to avoid a particularly nasty situation. Let me consider the following scenario. Let's say we had one file on a server and two users, user A and user B, right? Let's say that first A performs fopen, then B performs fopen. So A acquires the file, and then B acquires the same file. Let's imagine that these are in, technically speaking, there's also a read-write mode, which is RW, which is what makes this example work, but you can do both at the same time, but it's not recommended, especially if you're just learning what it is for the first time. So, anyway, so A opens the file, B opens the file. A then writes to the file. What happens if B then also writes to the file? Right. When B writes to the file, the things that A wrote are overwritten. And most importantly, if I can just squeeze in A reads, yeah, sometimes they just start over. All right. So, further elaborating the scenario, if the original contents is C, A opens it, creates a local copy that he's working with called C, B also grabs a local copy C, right? A modifies this to produce the file A, and then writes it in. B modifies C to produce the file B, writes it in, overwrites A's changes. Right? B will have never seen the stuff that he's overwriting. Right? A's work is lost irrecoverably because we are not in a scenario where a trash bin exists, or the recycling bin, or whatever it is, where good files go to be deleted. Something like that. So, what could have prevented this horrible tragedy, this horrible loss of data? If A performs flock, and yes, I know it spells flock, the flock operation establishes a perimeter around the file which has been accessed so that any attempts to open it by another user will fail until the lock is released using fclose. In most circumstances, the behavior of fopen in PHP is to basically do a thread.sleep in Java until the resource is released. So it just kind of shuts itself down, periodically checks back to see if the resource has been released, And then if it waits too long, it'll like time out a failure condition. But in general, fopen will wait until the lock has been released, right? So this is useful and important. Yes. So flock, you want to throw your file handle in there as well. There are two modes on flock. One is for reading and the other is for writing. For reading, you don't actually require exclusive access, right? This scenario requires writing to really cause damage, right? Writing is when you need the exclusive lock. So, under a read scenario, you can have a shared lock. The lock is automatically released by the fclose operation. Make sense? So far, so good? Good. So, sorry, question?
What happens if you tries accessing the file when it's locked?
The fopen operation will hang until the resource is released, assuming it's been locked exclusively.
Okay.
Makes sense?
Yeah. So then when it closes, the information that B wants to put in file will
Yeah. So if A has locked the file, B has to wait until it's been unlocked, and then he can do whatever he wants with it. Yeah. Assuming that it's an exclusive lock because you're doing some writing to it. Any number of people can read something at the same time, that's fine. In practice, this type of thing happens only very rarely, this problem. This is what's known as a race condition. Race conditions in computing mean basically, it's like a reverse of a race. Whoever gets there last wins the race, right? Whoever is the least recent person to, or whoever's the last person to write to the file, they're the only person who wins. So that's the type of thing that we want to avoid. Avoiding that type of thing is the whole purpose of revision systems and subversion, or what's it called? Git and GitHub and those types of repository software. Yeah. A big part of the purpose of those pieces of software is to prevent race conditions between people working on the same file. So, good. So that's an example of reading. Let's do an example of writing, shall we? So, file name is newfile.txt. Because we've closed the file handle, it no longer contains any useful information. We can reuse the variable name if we want to. I am going to. You don't have to. Fopen file name. This time we'll open in write mode. Since we're opening it in write mode, we want an exclusive lock rather than a shared lock. Make sense? This is the one that really does stop any other attempts to open the file until we are done with it. I suppose I should actually put this step after checking to see if the operation succeeded or failed. Eh? So, in fact, like, actually all of this should go in here. Now that I'm thinking about it. So what I was doing there, incorrectly, I was checking to see if the file failed to open, and in the case where it did fail, like regardless whether it opened or didn't open, I then proceeded to try to lock it and read from it, which is stupid. So all of the stuff that actually works on the file is dependent on the file handle existing. So that should be actually in the if statement. Unless you're using like a break or some kind of thing to control flow differently. So, So, to write to a file, you first need some string data, because it's a string that we're going to be writing in. So let's say data is equal to my how much I random words I sent. Just string data. Why are you complaining? Oh, yes. Because it's bloody PHP, that's why. Alright. Have to say, of all of the bits of PHP, not a fan of the dollar signs. You do? No.
Where he tested the dollar sign today.
So, the function which writes data to the file is called fwrite, as seen over there. Fwrite. You have to provide the file handle, and then you provide the string data. In this case, I've actually literally called it data. And of course, when you're done, you close it. If the file doesn't exist, it creates it. If the file does exist, it overwrites it. So, if I run this, in my folder, where is it? New file.txt.
So fwrite will create the file if it doesn't exist?
Fopen will create the file. Yeah, if it doesn't exist, fopen creates the file, and if you have no fwrite at all, it will just be a blank file. Isn't I have the wrong block setting? Oh, no, it's there, okay. I think I had it right. Let me see here. New file, delete, save, reload. Okay.
Because you're not at full?
No, it's Explorer didn't refresh.
Oh, okay.
Yeah. You have to refresh Explorer to see the file. But here's the file, new file. Notepad. And there's the string. Ta-da! a very common pattern is to read the file, perform some manipulation, then write the same file back with some slight modifications. That's a very common thing. You guys remember the tic-tac-toe example I showed you at the beginning of the semester? That's an example of that. Like the tic-tac-toe state is held with, it's just held in a file that has like, and I think it's like U for unused or something. That's the entire contents of the file. Every time someone makes a move, it just reads this file in, replaces the appropriate U with an X or an O or whatever, and then writes it back to memory. And then there's a separate PHP script which updates, no, it also sends that data back to the client once it's performed the update. But everybody's, the way that's configured, everybody is checking back with the server every half second for updates anyways, so. But that's just a read operation. So there we go, there we have it. Any questions? Seems pretty straightforward, not too bad. Yeah, it's not too bad, file I/O. Really, it's the security stuff that's useful to know about it, right? Especially in the context of a server. But this is like baby's first databasing. This isn't like really databasing because we're not using a properly structured database that we're sending queries to, but like, you know, in theory, you can do everything that a database application can do just with this. In theory, if you wanted to spend, 3 years of torturous hell trying to basically recreate SQL from scratch. But it could be done. This is the way that they do it. So, yes, good, excellent. Let's see. Yes. While I'm here, let me demonstrate append mode. A. Anybody want to take a guess? What does append mode do? Yeah, so when you write stuff in append mode, you're adding it to the end of the file rather than overwriting the file. So if I switch that, come back here, reload, 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 close the file, open her back up again, it has been appended. Note that it doesn't automatically include new lines, right? It put all of that on one line. And that's a very useful thing to know about writing two files, is if you want a new line, you have to put a new line with a new line character. Sound good? Wonderful. So let's talk a little bit more about how files are stored and the nature of the file system. Also, the nature of different operating systems. So, the way that files are stored, let's talk just about text-based files for now. This was a standard that was established way back in the late 1960s, during the development of the Unix operating system. The Unix operating system had a number of key innovations which were so awesome, every single operating system since then has stolen the ideas. Number one is a hierarchical file system that includes folders or directories. That was a Unix invention. Another Unix invention was that files should by default be text encoded. Prior to Unix, you were you were like in the era when there was so little memory available that like whether you had something binary or text encoded actually mattered, like because you were counting every bit. But you know, by the 60s, we had enough memory to be able to text encode things, so we did. The Unix standard for text encoding is to use the new line character. Windows systems tend to use two characters, R and N, and older Macintosh systems use R alone. So R and N are both old electric typewriter operations, right? The ASCII code, which was adopted by computers because someone was like, hey, we have electric typewriters, we have computers, right? So a lot of these conventions originate in electric typewriters. N is the operation for line feed, which is, you have to imagine a you guys have seen a typewriter before?
Yeah.
I mean, yes, I know, but like, I don't know, with Zoomers, you can never tell if they know something, you know? Or perhaps just a, I don't know. Wow, people are still buying parts for these things?
Yeah.
Incredible. I mean, mechanical ones I can understand, right? But, okay.
So there's only parts for literally everything.
Yeah. So this is a typewriter. All right? You have a fixed point of contact on the paper where the print head strikes the paper. The paper is loaded into a carriage, and it's a roller, so when you reach the end of the line, the carriage returns to its the carriage returns to its original position so that the print head can start printing again, and then the paper is fed just enough so that you have the next line available, right? So those are two separate operations. The part where the carriage is rolled a bit, that's new line, and the part where the carriage is returned, that's carriage return R. So, so Unix thinks that the line feed itself is the only important part. They're kind of right, because one of the things that was very quickly developed in printers is a movable type head, right? Typewriters tend to have a fixed typing head, but you know, that was one of the things that was quickly changed. Windows is kind of like the old version, both carriage return and new line feed, and then for some reason Mac just uses carriage return, right? But if you look at a Mac keyboard, what does it say instead of enter?
Return.
It says return. There you go. That's why. That's why Mac says return instead of enter. So, the thing that you should be aware of, I created my text files in Windows, so they might have these two characters at the end of every line instead of just one. That being said, when you load things to CS Unix, you will be loading them onto a Linux machine, which means the expected line ending is just regular new line. So, basically, if you're swapping between operating systems, you might encounter problems. A much more interesting problem is that of directory navigation. So let's say, just for the sake of interest, rather than dumping all of my files in the sort of the directory here, I wanted to start putting things in subfolders, which is a very reasonable thing to do, especially if you have a lot of folders, right? New folder, sources, drop those in there. The way that you access something in a subfolder is to include that folder's name and then the slash character. So, resources slash new file resources slash. So welcome to the slash wars. And here's the part where it actually does matter, right? Unix, Linux, Mac uses / to indicate directories. Windows, anybody know which one? It's / Windows uses / to indicate directories. Does anybody know why? Because they're the only people who do it. Anybody want to take a guess why Windows did that way?
Be different?
Correct. Literally, the entire design decision was made. We don't want to be too similar to Unix.
Boo.
So, they made their slashes go the wrong way. And this is the wrong way. Can anybody tell me why this is the wrong way? Think about strings. Yes, that's the escape character. Idiots. All right. Basically, if you're specifying a directory in Windows as a string in a programming language, you have to escape your backslashes. Right? How stupid is that? It's pretty stupid. I'll answer that one for you. So, this is of particular importance if ever any of you have to operate on a Windows server, which is entirely probable. Well, maybe. Overwhelmingly, the majority of the servers that are running out there in the wild are Linux/Unix servers, because it's way more efficient. And why wouldn't you? Because it's more efficient. But there are a certain number of Windows servers kicking around because, you know, big companies love Microsoft. So it's entirely possible that you may have to use a Windows server at some point, in which case you should be aware that you have to do this to file directories. All right. Okay. So here's another one though. And we're going to ignore Windows for now, which is only just. In Unix/Linux, probably Mac too, there is a special file name that exists in every single directory. It's called ... Can anybody tell me what 2 dots do when they're in a file path?
Go back to the previous thing.
Yes. This returns you to the file, the directory one level above in the hierarchy, right? So basically, it's possible to, if you're allowing users to upload files and upload file names, it's possible for them to encode the file names with these little guys, and if they can guess the directory structure of your content on your server, then they can, they can perform a, what is it called? A directory traversal attack, which is kind of fun. So we're going to do this when we do files, but when you upload a file to a server, your file name travels with your file, right? And if the server is unintelligent about how it handles that file name, and it just assumes that it's correct, let's say in the case of this particular server, let's say it was ... index.html. Right? This as a file path, if you write to it using this mechanism with no further scrutiny, allows someone to upload their own index page to your server and overwrite your own index page. Now here's an additional little trick with it, right? Your index page is public information, right? Because it's public information, anybody can just yoink a copy of your index page, throw in a couple of nifty little scripts to do who knows what, and then, if you don't protect against this sort of thing, you, yourself, will write their code right back to your own server, right? Yes. So when you are looking at file names, please make sure there's none of this kind of nonsense going on. Nasty, right? Yeah. So, good. Okay. I'd like to show you one more thing while we're on the subject. So, this is all well and good if the data that you want to retrieve and store is string data. But let's say, just for the sake of argument, that it's not string data, right? Let's say that it's, an array that contains numbers, as they often do. Let's say, for example, something like that. How do we store this? It's not a string. If we just give it to fwrite, that's not going to work very well. Anybody have any idea? You already know the function.
I can't do this.
Hmm?
Didn't we do this last semester?
Yes.
I don't remember.
So, we have a data structure. We know that text-based files only accept strings. How do we convert from a data structure to a string? Hmm?
You get ready for it with a for loop and then you do it above.
I mean, you could do it that way. It's painful though, you know, compared to this lovely method that I'm thinking of that nobody else is thinking of. Okay, yes?
So if you're saying that that is in the text file, like that array,
I want to store this in a text file.
you I guess, like, did you like, put it as like a cast or not? Casting it?
No, you can't cast it as a string. Because the question is, if I'm a casting operation and I look at this, I'm like, am I supposed to interpret the numbers as characters? Like,
Yeah.
what kind of conversion is going on here? Starts with a J. That's it. JSON encoding. Boom. That's right, folks. The JSON encode function takes arbitrary data structures, arbitrary collections of both arrays and associative arrays, and converts them to a string. We have been using this primarily for firing packets off through off through the internet, because that also is expected to be a string, and decoding it on the other side. But you can use the precise same method for storing data like that inside of a text file on the server. So, let's do it. Actually, you know what? I'm going to just pop this over and use this one. And you can't stop me. So, instead of just being random garbage, JSON encode our array. And then, if we wanted to read that file back, it's a slight degree more complicated. Oh, this is in append mode. That'll never do. There we go. So the problem here is that our fgets function reads in one line at a time. If we want to keep using it, we will have to append all of the lines that we read into one string and then decode it, right? So data is equal to data append or concatenate.
Screaming over dollar signs,
And then echo or new array is equal to data JSON decode. There, like that. Right? We encode it on the way into storage. We decode it after we've read it from storage. Make sense? So, if we save that up, reload, there we have it. Right? And if we had something fancy in here, like maybe the last element is an associative array, A gets B pineapple gets something like that. Rerun that. You can see that our associative array has been inserted into our JSON in the manner that you would expect. Right? And then, once we have the data decoded in new array, we can new array, what index is this? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 at pineapple. Interesting. Let's see what's going on here. Notice array to string conversion 1.48. Yes. Oh, well, let's see here. Okay, so 2, yeah, okay. 9. Yeah. But I want an index. Weird. Why can't I access this? Have I got the index wrong? One, two, 9, yeah. I don't know why I can't just like call it. Okay. Somehow I was just messing up direct addressing. I don't know. I got the data data though, and it's totally an associative array because the for each loop works. So we got that far at least. Does that make sense? Question?
I was just looking at this, so one of the things that's just here is like casting it to the greater than.
Oh. Maybe. But it's an associative array, but okay, let's try it. Cast it as an array.
I'm a beginner problem solver, this is what we will try it.
I'm gonna see if I can, so JSON encode cast as array, assign that to the code e cast. Okay, see if that works. Undefined index A. Oh, okay. Well, whatever. Good. Yeah. Any questions? So, a word on file extensions. There are generally accepted file extensions that one should use. Like, if you're encoding JSON data, really here I should be calling this new file .json. Not XAMPP, JSON. An interesting thing that you may not be aware of is that web browsers can also read. Oh no. File open failed. Oh yeah, because I need to write to it. Not. There we go. If you have JSON data, you can navigate it with a web browser, which is kind of useful, right? But especially if they get long and complicated, which they're likely to. But yeah. So this is all I have on this topic. So we might as well start with the next one because we got 27 minutes left in class, or however long it is. I think it's 27. Anyway, so wait, no. 17. Pardon me. So, accepting uploads. So, reading and writing files to the file system is an incredibly powerful tool. The power of that tool will almost certainly exceed the skill of the person using it, because it is an incredibly powerful thing. And I'm including myself when I say that. So, if it's easy enough to goof it up when it's just you writing your own internal data files, allowing the user to upload files of their own design to your server is an inherent, incredibly powerful security risk. just a whole heck of a lot of things that could go wrong. That being said, file uploading in web applications is quite common. What's an example? When do you upload a file?
Posting a new photo to Facebook.
Sure, posting a photo to Facebook or updating an avatar or something like that. Something else? When do you upload a file? Submitting homework to Canvas, yes. Absolutely. Uploading a video to YouTube, you know. Anytime you are transferring a file, this is what's going on. So, file uploads use post requests rather than get requests. It's kind of like, if you think about what post might mean as an operation, it's like, here, post this, right? The size restriction on a post request is pretty big, right? And the payload is encoded, like encrypted in the payload, as opposed to a GET request, where it's just in the URL. URLs have a hypothetical character limit of 4,000 characters. Most files that you would be working with are well in excess of that size, so even if you were inclined to character encode an image file and send it through GET, that's a terrible, terrible idea, and you should be slapped in the face. So, use the right response packet, or use the right encoding into these packets, please. So, most of the data that we've been sending so far has been string data, but post requests also have the ability to send binary encoded data, right? Things like image files. Image files, video files, and music files as well, or sound files. So, there are many more steps of validation that are required for user-sent files, just because the inherent nature of it is way more deadly. But, you know, a lot of like very important internet functionality comes from this. So, this is one of these parts of server programming where we are kind of bumping up a little bit against what the server administration classes in the networking stream teach. There is a configuration file called php.ini, stands for initialization. There's an area in this configuration file which sets the ways in which the server can receive files by post request, or whether it can even do that. So, let's take a look at this file. It's located in a different place in pretty much every server. So whatever server type and version you're using, you'll have to look for PHP. Or, if you are a super expert Linux user, you can just find the file using like the find command or something like that. But in XAMPP, you've got this PHP folder, and in this case, it's very useful to allow file name extensions to be viewed, because holy crap. There it is, php.ini. Let me blow that up for you. php.ini. If we open that with a plain text editor, this is our PHP configuration file. Now, for XAMPP, you actually have the ability to modify this in any way that you would like. It's your own local running server instance. On CS Unix, You have nowhere close to permission to modify this, right? I don't have permission to modify this. The only people who have permission to modify this are the sysadmins, capital italics underscores. The IT department administers the CS Unix server, and they are the ones who modify these configuration files when they need to be modified. At the beginning of the semester, actually, this very semester, one of our departmental professors who was checking to make sure everything still worked, which is always a good thing to do, noticed that the IT people had actually disabled file upload to CS Unix at the beginning of the semester. And so we had to have them go into this very file and fix it. Incidentally, that's completely unrelated to any outages of CS Unix that you guys were having like a couple of weeks ago and that sort of thing. All that was happening was post requests containing file uploads were not being serviced by the server. So, it's a pretty long initialization file. You can tell it's got, it contains a lot of documentation. But if you just search file underscore in here, you get the file uploads area of the configuration file. You can see we have file uploads turned on. We have the upload temporary directory. We have a max file size which we can upload, in this case 2 MB. And we have max files that can be uploaded. So it's possible to encode more than one file in a post request to be sent to the server. The default on the Apache distro on XAMPP is to limit it to 20 files at once. So, this is all well and good. So, this is the process that the server takes when it receives a post request which uploads a file. The first thing it does is it saves that file to whatever its temporary directory is. While it's doing this, it scrambles the name. The file name, remember, can contain directory traversal attacks. So, before it saves it anywhere, it scrambles the name so that those directory traversal attacks are prevented. Once that's been uploaded to the temporary directory, in PHP, we then perform any checks that we think are necessary on the data that was received with the file and the file itself. But from the perspective of the PHP script, the file contents and reading the file contents is simply accessing things using the temporary file name. If you want to copy that file to a local directory, that's what you're doing. You're copying a file from one directory to another. You're not specifying its initial point of entry into the system. That's not what you're doing. You're simply copying it from the temporary directory to where you think it should go, if you think it's safe. Make sense? So far, so good? Yeah, we'll do examples and hopefully it will become more clear. All of this is reflected in commands. So yeah. So I'm showing you this not because I ever think that you will need direct access to this, but I'm showing this to you so that you can intelligently talk to a sysadmin. Right? It's like, man, every time I'm trying to get file uploading working, I'm testing this out and I'm just getting this weird server error every single time. Do you think you could just maybe check php.ini, and if you know where it is, you can in fact go and check it yourself. In Unix, you can read files, you can read most files with even like regular user level permissions. But to modify the file requires super user privileges, which is what the sysadmin will have. Yes. So, yesterday I tried for about an hour to get file upload via Ajax post request to work. I was eventually unsuccessful, and I decided to do what everybody does, and check out the example on W3 Schools. PHP, I need a search engine, thank you. PHP file upload. So, the way that this example works, it's using form submission and the automatic HTTP request packet that's generated upon form submission, right? This is kind of your HTML and CSS course way of going about things, right? But it does have the advantage of like not having to marshal the data yourself in JavaScript. And I don't know about you, but like the less JavaScript I have in my life, the better my life goes. You know. So the action is of course targeting the PHP script that will handle the upload. Method is post, and then this is an interesting one: encoding type, multi-part or form data. Because this is being sent through form data. It's sent through a form, the encoding should be form data. So, once we have received that packet, much of the information that's contained about the file is saved in the file's superglobal. When you send the file through, you give it a name corresponding to the name of the input element. Oh, you guys won't have seen the file upload input, the file type input element, right? Because you wouldn't have had any purpose for it before now, right? So, so you know those little choose file dialogues that open up the open file dialog, those things? That's what this is. So anytime you see that, that's just this input element which has been using. This name corresponds to the, so when you have the file superglobal, that's an associative array at the first level between all of the file names that have been, for all the files that have been uploaded, and the information about those files. So you need to know what file in all of the files you're accessing. So that's the first element there. After that, there are various properties that you can access using the secondary associative array, which is contained within that associative array. Class is dismissed. We will resume this on Friday.